So guys, let's continue with our lecture 2. This whereby we are gonna tackle what is cryptography. So cryptography is the science and art of securing communication and information through the use of mathematical techniques. What do we mean by use of mathematical techniques? This is the technique whereby it is this is the technique of converting readable data into a readable format, which is the readable format. It is cipher, to ensure that only authorized parties can access the information. And in our Greek word, the term crypt means hidden, and the suffix graphy means writing. So whereby you will find that this art of cryptography started from an early age. That's the ancient civilization, even the classical era, and then the modern cryptography. That's the 20th century onward. So objectives of cryptography. So the objectives of cryptography are confidentiality, integrity, authentication, and reputation. And the application of cryptography, it is secure communication. It is used in e-commerce sites such as the SMS. It's used in digital signatures. It's used as a discrete essential to ensure authentication and reputation in legal and financial documents. It is even applied in data storage and keeps sensitive data in a database and cloud services. It is applied in networking, where it secures VPNs, Wi-Fi, and other network protocols. These are the terms we are gonna come across. The plaintext. The plaintext is the original readable message or the data. Ciphertext, the encrypted and readable form of the plaintext. Another term is encryption. Encryption is the process of converting a plaintext into a ciphertext. Another term is decryption, whereby this is the process of converting a ciphertext into a plaintext. Other term is a key. A key is a piece of information, can be a number or a string, used in encryption and decryption. Then there's the algorithm. This is a mathematical formula or procedure used for encryption and decryption. This is the process of cryptography, whereby you get the plaintext here. Then this is a confidential memo. Then it must go to the algorithm, encryption algorithm, in the presence of a key. In the presence of a key, then it's converted to a ciphertext. Then it is transmitted to the remote user in form of a ciphertext. Then it is decrypted again using the decryption algorithm and the key to get to the receiver as a plaintext. So that's how the process occurs. So you find that there's the classical cryptography. This refers to early methods of encryption that were based on pen and paper techniques and mechanical devices. So there are substitutional ciphers. This whereby they replace this letter in the plaintext with another letter. Example, this is used in Caesar Cipher and monoalphabetic ciphers. There's even transposition ciphers, which enable the use of rearrange the letters in the plaintext according to the specific pattern. Examples are the relevant ciphers. Then there's another kind of a cipher. It is polyalphabetic ciphers. It uses multiple substitution alphabets to encrypt the plaintext. An example of it is the figure cipher. Then there is now the modern cryptography. This relies on mathematical theories and computer algorithms to secure data. Examples of modern cryptography, it is the use of block ciphers, stream ciphers, public key infrastructure. So you find that in block ciphers divide plaintext into fixed size blocks and encrypt each blocks. An example is the DES and AES. Stream ciphers, they encrypt data bit by bit and byte by byte in real time. Examples are the RC4 and the public key infrastructure. These are frameworks that use asymmetric cryptography to issue and manage digital certificates. Now here we have the classification of cryptography. How is cryptography classified? Cryptography is classified according to the number of keys used. And when we talk of number of keys used, it depends on the number of keys used required for encryption and decryption. And an example is the hash function. So in cryptographic hash functions such as the SAH256 and MD5 do not require any key. So another example of under classification of number of keys used is asymmetric secret key cryptography. So this whereby the same key is used for both encryption and decryption. Example is the DES and AES or the bluefish. And another example under classification of number of keys used is asymmetric public key cryptography. So this one uses a key pair, a public key for encryption and a private key for decryption. The example is the RSA and ECC. So another classification of cryptography is according to the type of encryption operations used. So the type of operation applied during the decryption process can be divided into substitution ciphers, transposition ciphers, and product ciphers. So when we talk of substitution ciphers, this whereby they replace the elements of plaintext with corresponding elements from a substitution table or algorithm. So an example is the Caesar cipher. Under the classification, under the type of encryption operation used, there's another example of transposition ciphers. This one, they rearrange the position of plaintext elements according to the predefined rule. This example is the rail fence cipher. And then at the end of it, there's the product ciphers, which is a product of combining substitution and transposition operation to enhance security. An example of it, the DES. Then another classification of cryptography is the way in which plaintext is processed. So the approaches of processing plaintext during encryption can be categorized into the block ciphers, stream ciphers, and stream ciphers. In the blank ciphers, is whereby the plaintext is divided into fixed size blocks, and each block is encrypted independently. That is the example of AES, the Advanced Encryption System, whereby it used 128-bit blocks. And the stream ciphers, the plaintext is encrypted 1 bit or a byte at a time using a continuous generated key stream. Example is the RC4. Then now we have the symmetric encryption. This whereby a single key is used for both encryption and decryption. So an example is this whereby plaintext. This plaintext is encrypted using once as the same secret key, then you say the same key for decryption. So you find that this is the ciphertext, this is the plaintext, this is the plaintext. So this is the sender, this is the receiver. But you find that there's one thing common: they use the same key for both encryption and decryption. Components of ingredients of a symmetric cipher. So there's the plaintext. This is the original readable data or message. Then the encryption algorithm has mathematical function that transforms plaintext into ciphertext using a key. Then there's the key, a critical piece of information that determines the output of the encryption algorithm. Then there's a ciphertext, the encrypted and readable output of the encryption process. Then the decryption algorithm, a mathematical function that transforms ciphertext back into plaintext using the key. Then there's another example. We have both asymmetric cryptography and symmetric cryptography. We have said that symmetric cryptography is whereby it uses one key element for both encryption and decryption. And asymmetric, under this system, a pair of keys is used to encrypt and decrypt information. So a public key is used for encryption, and a private key is used for decryption. Note that in asymmetric cryptography, there's use of a public key and a private key. Public key is used for encryption, a private key is used for decryption. So even if the public key is known by everyone, the intended receiver can only decode it because he alone has the private key. Uses two keys instead of one. The public key known to everyone, the private key is unknown by the recipient. So an example, this is the diagram whereby we get the plaintext, the encryption. Hereby you find that the public key is the one used for encryption, and these are two different keys. So it gives you the public key to a ciphertext. The decryption is used in the private key, the secret key for decryption. So hash function, these are mathematical algorithms that take input data of any size and produce a fixed size unique output known as hash or a digest. So in here, there's no usage of any key in this algorithm. The hash value makes it impossible for contents of plain text to be recovered. So these ones, they are designed to be irreversible. You cannot reverse. As you have converted into ciphertext, you cannot reverse it to plain text. So they are designed to be reversible and ensure that even a small change in input drastically changes the output. Hash functions are widely used for data integrity, digital signatures, and password storage. For those people who have used MySQL, you find that the passwords are always hashed. So yeah, are always hashed for security and protection. So the hash function, this is an example of a diagram of the hash function whereby there's no use of any key. You can't see any key here. So it's plaintext to hash function, then to hash test, then it produces the hash test. So we have the hashing algorithm in between. Okay, let's go on. Then Steganography. Steganography is the art and science of hiding information by embedding messages within other seamless, harmless messages. This technique hides data in a file or message in a way that makes it difficult to detect. So the word steganography comes from a Greek word, that's the steganos, meaning hidden or covered, and graph meaning to write. So whatever appears to be a harmless image can contain hidden data embedded within the image. So steganography works by replacing bits of unused data in a regular computer file with bits of different invisible information. So we have types of steganography. That's the image steganography. Image steganography. This whereby it hides data in a digital image by changing pixel values. Another example is the audio steganography. This one hides data in a audio signal by modifying it in a way that's imperceptible to humans. Another one, we have the video steganography, hides data in a video file by embedding it in the videos, images, or audio. Another example is the text steganography. It hides data in a text file by changing the format or words in the text. And the final one, we have the network steganography, hides data in a network protocol by using the head field, payload field, or both. So now we have the cryptanalysis. Cryptanalysis is the art of breaking cryptography systems to reveal the plain text or key without authorization. So when we talk about cryptanalysis, this is whereby an hacker tries to identify the original information from a ciphered or encrypted data. So these are examples of cryptanalysis include the brute force attack. This whereby the hacker tests all possible key combinations and if the correct one is found. Then there's the ciphertext only attack. This one is the art of analyzing ciphertext to reduce the plaintext or key. Then there is the non-plaintext attack. This whereby you use the non-plaintext and corresponding ciphertext to deduce the key. That is the man in the middle attack. This involves the intercepting and altering communication between two parties. Now this is a diagram of cryptanalysis. This whereby the plaintext, the encrypt, that is an encryption key. Then here it's ciphertext, then to decrypt, then to plaintext. But in between encrypt and decrypt, there's a cryptanalyzer. So plaintext or something useful. This whereby you find that we have Alice, Bob, and then there's Eve. This whereby that Alice sends information to Bob, but Eve is in between. Eve is the man in the middle. Eve is trying to intercept and alter communication between Alice and Bob. So Eve here this case is the cryptanalyzer. Yeah. Have a good day, guys, and have a good time. Next time it was a nice lecture. Kindly subscribe, like, leave a comment, and share widely. Thanks a lot.